In the name of Allah, the most compassionate, the most merciful, and may the peace and blessing of Allah be upon His last and beloved Messenger Muhammad, and may the peace and blessing of Allah be upon you all. The title of this presentation is A Strong and Light Structure from the Quran. Now, the title of this presentation stems from a problem in engineering. Now, this problem is that engineers, when they want to have a strong and stiff structure, they always end up with a heavy structure. Let me give an example. Suppose an engineer wants to increase the strength of a car, of the framework of a car. He ends up with a heavier car because he uses heavier materials in the construction, because a heavy material is a stronger material. And this is a problem. Why? Because when you have a heavier car, it consumes more fuel, and there is a phenomenon called self-loading, which means that the car itself, it puts so much stress on itself due to its own weight. And so it's a problem. So engineers dream of a structure that is strong and stiff and at the same time light. And in engineering sciences, there is no solution for this problem till this day. But I'm presenting here a solution for this problem from the guidance of the Quran, from the guidance of the last revelation of Allah God to people. And the key to find the answer to this problem, we can find it by pondering upon verse number 7 of chapter 32 of the Quran, which reads, "Who perfected everything He has created, and He began the creation of people from mud." So here Allah God Almighty is telling us that He perfected everything He has created. And in engineering terms, this means that every system in creation is an optimal system, is optimized, meaning the best utilization of energy and matter. So linking this by pondering upon load-bearing structures in creation, like for example human bone, we see that it's strong and stiff, and at the same time it's very light. These are load-bearing structures in creation. So if we link the Quranic verse that Allah Almighty created everything, perfected everything He has created, with the fact that load-bearing structures in creation of Allah Almighty, like our bones, eyes, beehive, they are strong and stiff and at the same time very light. So by studying these structures, we can understand how we can build structures which are strong and at the same time light in weight. So if we start by pondering upon the structure of ice, water, we see that it has a hexagonal design, a hexagonal internal design. So what you can see on the screen is the basic structural unit of water. We have 6 sides supported by 6 links. And this basic unit we can find also in the design of beehives. The way Allah Almighty created beehives, we see again we have a hexagonal cell supported by 6 external links. And also in wood material the same, we have cells, hexagonal cells supported by 6 external links. So what we end up with is that the basic structural unit in creation is the one you can see on the screen, 6 plates or 6 structural units and supported by 6 external links. So 6 plates supported by 6 external plates. Now, again, the fact is that beehives, human bone, wood, they're all light structures but at the same time very strong and very stiff. So the answer to how these structures can be strong and stiff and at the same time very light is found in the study of this basic hexagonal structural unit of creation. So if we start studying this basic structural unit of creation, and just for comparison purposes, I want to compare its performance with a typical structural unit currently utilized, which is the square kind of sections and the rectangular sections. For example, the room you are sitting in, it has maybe a square design or rectangular design. So I want to compare the performance of the hexagonal basic structural unit of creation with the typical structural units used in the construction nowadays. Now, firstly, the hexagonal basic unit of creation, since it has a hexagonal shape, it can cover maximum volume with minimum amount of material. Suppose you have certain structural plates and you want to cover the maximum volume or the maximum area with the minimum amount of plates. The hexagonal shape is the best one to do that. So since you are covering maximum area with minimum amount of material, you will have a lightweight structure. That's the first advantage of using hexagonal arrangement rather than square or rectangular arrangements. Secondly, if you look at the links between the plates, here is the link between three plates in the hexagonal design. Now this link, if we test its performance by applying a compression force or a compressive force from the left, as you can see with the red arrows, and fixing the ends on the right, so this compressive force, in this case, it will yield a displacement of about 34 micrometers. Maximum displacement in the link of about 34 micrometers. And if you apply the same compressive force to the typical sections used nowadays in construction, it will yield a maximum displacement of 464 micrometers. So in the hexagonal design, the displacement was about 34 micrometers. Here we have 464 micrometers. And if we put on a bar chart the two values, we see a huge difference between the displacement value in the typical kind of or traditional sections indicated by the red rectangle, and with the displacement values in the hexagonal arrangement indicated by the blue rectangle. So you see that the hexagonal design has far smaller displacements than the typical square sections, which means that the hexagonal design is stiffer than the square arrangement. And that's what we are looking for, a very stiff and strong design. Also, if you look at the stresses produced in the section, in the hexagonal arrangement, we see that the maximum stress is around 1 megapascals, 1 million unit of stress, and in the typical section we have is equal to about 1.6 megapascals. And if we compare between the two values, we see a 50% decrease in overall stress values in the hexagonal design compared to the traditional sections. So we see that the stress produced in the hexagonal shape is smaller than the traditional one, which means that you can apply more force or more load to the hexagonal design before it reaches fracture point. Now take this comparison to the whole structure, to the whole basic unit. As you can see on the screen, we have the basic structure unit of creation, and I applied a pressure of 10,000 pascals to its front surface, and the maximum displacement was about 3.5 micrometers, and I applied the same pressure to the square section, traditional sections, and the displacement was about 3.7 micrometers. And again, there is a difference in the displacement value between the two, where smaller displacements are seen in the hexagonal design. So this means that the hexagonal design is a stiffer design compared to the traditional sections. And also looking at the stress values, we see that under a pressure of 10,000 pascals, the hexagonal design yielded a maximum stress of about 13,361 pascals, and in traditional sections we have 18,133 pascals. So we see that there is a 36% decrease in overall stress values in the hexagonal design. So this means that the hexagonal So this means that the arrangement of structural units in a hexagonal design yields a stiffer and stronger structure compared to the traditional design by using squares or rectangles. So linking everything I've said so far, that the hexagonal design can cover maximum volume, maximum area with minimum amount of material, and the fact that it's stronger and stiffer than any other design. This means that the problem engineering now is solved. We can get a strong and stiff design by arranging the structural units in a hexagonal design. We can get this kind of combination of having a strong and stiff structure and yet it's light in weight. Let me give a practical example of this. The room you are sitting in, instead of having the walls in the square or rectangular pattern, putting them in a hexagonal cell. In this case, you can use lesser material, structural material, and end up with a stronger and stiffer design, which is the aim. This is the optimal system. Strength and stiffness with low or light weight. So we see, brothers and sisters, how from the Quran, from the last revelation of Allah to people, we get the answer to a question that eluded engineers till this day. And to know more details about this topic, please visit our website at www.quran-miracle.com, and you can email me at sayyidquran@yahoo.com, and may the peace and blessing of Allah be upon you all.